Okay, students, so let's get started with current electricity past papers, MCQs. So let's start with the first question. A charge of 45 coulomb flows through an electrical appliance in 3 minutes. Okay. What is the average current in the appliance? We have to calculate the current. Current is equal to charge over time. What is your charge? 45 coulombs. What will your time be? Always remember that you give the time in seconds. So 3 into 60, you can place 3 into 60. Why? Because you are converting minutes into seconds. 0.25 ampere is your answer. A is your answer. Let's further move ahead. In which example is the current equal to 1 ampere? Okay. So we have to calculate the current for all the examples and we have to see in which example is it equal to 1 ampere. Let's check out option A. We have a charge of 0.1 coulomb. Current is equals to charge over time. Charge is 0.1 coulomb and the time is 100 milliseconds. Okay. So whenever you have milliseconds, what will you do? You will place 100, and whenever you have a power of milli or a prefix of milli, you will multiply it by 10 raised to the power of minus 3. Multiply by 10 raised to the power of minus 3. Your answer for current comes out to be 1 ampere. A is your answer. Let's further move ahead. The diagram shows a circuit. The ammeter has 4 different range settings. Okay. Which range settings gives a reading near the midpoint of the range? Okay. So this is 5 kilo ohm, this is 5 kilo ohm. Both of them are in parallels. What will be the combined resistance? 1 upon RT is equals to 1 upon 5 into 10 raised to the power of 3 plus 1 upon 5 into 10 raised to the power of 3. Your total resistance will be equal to what? 2.5 into 10 raised to the power of 3. You have a voltage of 12 volts. Can you calculate the current? Yes, V is equals to IR. Voltage is 12 divided by resistance 2.5 into 10 raised to the power of 3. Your current comes out to be 4.8 into 10 raised to the power of minus 3 ampere. As I have earlier told you, 10 raised to the power of minus 3 is equals to what? Milli. So this 4.8 into 10 raised to the power of minus 3 is what? 4.8 milliampere. Do we have any ammeter whose midpoint will be in that range? Not A, obviously, not C, not D. Yeah, B is your answer. If you have an ammeter whose maximum value is 10 milliampere, minimum is 0, the midpoint is roughly around 4.8 milliampere, I guess. Yeah, let's further move ahead. Let's see this. Okay, so let's see this question. A battery delivers a charge of 150 kilo coulomb. So this is your Q to a circuit before it needs recharging. Okay. Two headlamps connected in parallel to the battery are switched on. There is a current of 4 ampere in each lamp. Okay, let's say there is a current of 4 ampere in each lamp. This lamp has a current of 4 ampere and this lamp also has a current of 4 ampere. Both of these lamps have a current of 4 ampere. What will be the combined current? What will be the combined current? 8 ampere. Your combined current is 8 ampere. Your total charge is 150 coulombs. Can you calculate the time before it needs recharging? Yes, surely you can do that. I is equals to Q over T. What is Q? Or let's say you can make time the subject of your formula here. You can make time the subject of your formula here. Time is equals to charge over current. Charge is equals to 150 into 10 raised to the power of 3. Current is what? Current is 8 ampere. Divide it. Your answer comes out to be 150 into 10 raised to the power of 3 divided by 8. This gives you a value of 18750 seconds. But you don't see any answer like that here. You can convert these seconds into hours. 18750 divided by 3600. Whenever you have to convert from seconds to hours, you divide it by 3600. 2.5 hours is your answer. B is your answer. Let's further move ahead. Three identical lamps and three ammeters are connected as shown. Okay. The reading on the ammeters are I1, I2, and I3. How are the readings related? So if you closely look, I1 will be the greatest. Why? Because I1 is the current that further gets divided into I2 and I3. I1 will be the greatest. Why? Because I1 is the current that gets divided into I2 and I3. Let's say, for example, I am saying that I1 is 3 ampere. It will get divided into two halves between I2 and I3. So I1 will be the greatest, that's for sure. Now these are three identical lamps. What do you mean by three identical lamps? The three identical lamps means that this lamp will also have a resistance of R, this will also have a resistance of R, this will also have a resistance of R. Okay. So the combined resistance in branch 1 becomes what? The combined resistance in branch 1 becomes R. And the combined resistance in branch 2 becomes what? 2R. Do you remember resistance used to be inversely proportional to current? So if branch 2 or current 3 has a higher resistance, so current 3 will be small because it has a higher resistance of 2R. However, this branch, if I highlight this branch, let's say this one, if I highlight this yellow branch, can you see we only have a resistance R? That means I2 will be large or greater than I3. So what do we get? I1 is basically greater because that's the current that gets divided into 2. After that, we have I2. After I1, we have I2. Why? Because I2 has a smaller resistance. And then we have I3. Why? Because I3 branch has the highest resistance. Is there any option like that? D is your answer. So let's revise this once again. I1 is the highest current. Why? Because this will get divided among smaller halves I2 and I3. Furthermore, I3 will be smaller than I2. Why? Because I3 has a greater resistance in its branch. I2 has a smaller resistance. This will be your answer. D is your answer. Let's further move ahead. Let's see this question. During a thunderstorm, a lightning flash occurs when charge flows between a cloud and the earth. On average, 20 coulombs of charge flows through each flash, and there are 3 flashes every minute. Okay. So there are 3 flashes every minute. One flash gives you a charge of 20 coulombs. So how many charge will be emitted out by 3 flashes? 60 coulombs obviously. And this is happening every minute. Okay. What is the average current? Current is equals to charge over time. Your charge is 60, your time is 1 minute, 1 into the seconds in 1 minute, that is 60. Your current comes out to be 1 ampere. A is your answer. Let's further move ahead. The current in the car headlamp is 2 ampere. The headlamp is switched for 4 minutes. How much charge passes through the headlamp? So current is equals to charge over time. Current into time is equals to charge. Your current is 2. Time is 4 minutes. 4 into 60. This comes out to be your charge. Your charge comes out to be 480 coulombs. Let's move on to this. A charge of 7.5 coulombs flows through a resistor in 5 seconds. Okay. A student has ammeters with different ranges that he can use to measure the current in the resistor. Okay. Which ammeter range is the most appropriate? We have to calculate the ammeter range which is most appropriate. So current is equals to charge over time. What is your charge? 7.5. What is your time? 5. Your current comes out to be 7.5 divided by 5. This comes out to be 1.5 ampere. So which one is the most appropriate? B, because A cannot measure 1.5 ampere, C is too large, D is also too large. B is the perfect ammeter for this. Let's see this. 4 resistors of unequal resistances are connected to a power supply as shown. The current in 4 resistors are I1, I2, I3 and I4. Which equation is correct? Okay. For this, you need to understand how a parallel connection works. Let's say initially this current I1 is 3 ampere. I am just giving numerical values to make it simpler. It will first of all get divided into two halves, I2 and I3. Let's say this will have 1 ampere. Let's say this will have 2 ampere. Initially, if you have a higher current, let's say initially you arrive at this node with 3 amperes, this will get divided into two halves. Let's say 1 ampere and 2 ampere. I am just giving numerical examples. It could also easily get divided into 1.5 ampere and 1.5 ampere, doesn't matter. But the thing to note here is that current gets divided in parallel connection, and once the parallel connection finishes or parallel connection ends, it again combines. 2 plus 1 is equals to 3. You will again have a current of 3 ampere at I4. You started with 3 ampere at I1, you ended at 3 ampere with I4. In between, in the parallel connection, the current got divided. Okay. So which option will be correct? I1 is equals to I2 minus I3. No. I2 is equals to I1 plus I4. No. I3 is equals to I4 minus I1. No. I4, that is this current 3 ampere, which we have taken as a numerical value, is equals to I2 plus I3. Yes, D is your answer. Let's further move ahead. The diagram shows, sorry for this blurry picture. The diagram shows a circuit. Which circuit diagram shows this circuit? Okay. So this is the negative terminal. This will have a smaller line. This is the positive terminal, a bigger line. Then this has a negative terminal, smaller line. Then this has a positive terminal, bigger line. So these are the two batteries that I have made. This is only available in option A and D. B and C will get cancelled out. Can you see the lamps are also connected in parallel? So the only remaining option is A. Let's further move ahead. Again, let's see this. The current in different parts of the circuit are I1, I2, I3 and I4. Again, parallel connections. Let's say this current is 3 ampere. In parallel, it will get divided into 1 ampere and 2 ampere slots. It can also be 1.5 ampere and 1.5 ampere. It doesn't matter. But the thing that matters is that current gets divided in parallel and will again get combined at this node. 1 plus 2 is equal to 3 ampere. I1 is equals to I4. That's correct. I1 will be equal to I4. C and D can get cancelled out. Okay. I1 is equals to I4. Okay. And if you notice one more thing, if you notice one more thing, this branch I2 has a greater resistance. What have we studied? Resistance is inversely proportional to current. So I2 will probably receive a lower current, let's say 1 ampere. And I3 will be a greater current because it has a lower resistance. A lower resistance will receive a greater current. A greater resistance will receive a lower current. So I3 must be greater than I2B is your answer. Simple as that. Let's see this. In which circuit P and Q below resistors R1, 2 and 3 have different resistances? Okay. In which circuit are the circuits in the resistors equal and okay. In which circuits are the currents okay. In which circuit do we have the current equal in the resistors and in which circuit are the potential difference equal in the resistors? So this is a very easy question. Grade 8 student might also be able to do this. The currents are equal in series circuits. Where is the series circuit? Circuit Q. The potential differences are equal in parallel circuits. Where is parallel circuit? Circuit P. C is your answer. Let's further move ahead. Okay, let's see this. A potential divider consists of a light dependent resistor LDR and a resistor connected to a 6 volts battery. Okay. The output is 3 volts. Okay. So the total here is 3 volts. We have a 3 volts output. What will be the voltage across this 10 ohms resistor? 3 volts. Okay. What is the resistance of the LDR? We have to calculate the resistance of this LDR. How will we do that? How will we do that? Okay. Listen. We have studied in series that voltage is directly proportional to resistance, right? In series, we have studied that voltage is directly proportional to resistance. Can you observe that here a 10,000 ohm resistance is receiving a voltage of 3 volts? A 10,000 ohm resistance is receiving a voltage of 3 volts. So what will be the resistance of LDR to receive 3 volts? Apply ratio method. X comes out to be 10,000 ohms. Simple. Is there any answer like that? C is your answer. Let's further move ahead. A piece of paper torn out of an exercise book is shown. Okay. Dash is the work done measured in joules as unit charge measured in coulomb as it work done on unit charge as it moves around the circuit. So this can either be potential difference or electromotive force, not electrical resistance, not electrical current, not electric power. Electromotive force is your answer. Let's see this. This is very, very important. Quantity x and y have the same unit z. Quantity x is the energy dissipated by a battery in driving unit charge around the complete circuit. Whenever you are driving a unit charge around the complete circuit, that is known as potential difference, PD. Whenever work is done in a component in driving unit charge through that component, whenever you are driving a charge through a component, that is known as electromotive force. And both of them have the same units of volts. Is there any option like that? D is your answer. X is your potential difference, Y is your EMF, and the units are of volts. V, volts. Okay, let's see this. In the circuit shown, the resistance of resistor Y is 4 times greater than the resistance of resistor X. So basically, this is 4R, this is R. Okay. We have studied in series, voltage is directly proportional to resistance. So if X has a resistance of R, it will be receiving, let's say, a voltage of V, X. And if Y has a resistance of 4R, let's say it will be receiving a voltage of 4Vx. And I know that the total voltage is what? 10 volts, sorry. 10 volts is equals to Vx plus 4Vx. Vx comes out to be 10 over 5. Vx is 2 volts. The voltage across resistor X is what? Vx 2 volts. And the voltage across resistor Y is what? 4 into 2, that is 8 volts. 8 minus 2 is 6 volts. C is your answer. You had to calculate basically the difference between voltage of Vx and Vy. Which unit is the same as volts? Ampere over ohms, no. V is equals to IR, so it should have been ampere multiplied by ohms. Okay, let's see. Ampere divided by watts, no. Power is equals to IV, so watts divided by volts should have been the answer, not this. Which is equal to volt, sorry, this would have been ampere, not volt. Okay, let's see option C. Ohm over ampere, no. Volt over ampere, yes, this could be your option. Why could this be your option? Because if you closely examine, power is equals to IV. Power has the units of volts divided by the units of current, that is ampere. This gives you your units of volts. D is your answer. Let's further move ahead. 3 identical resistors are joined in series to a cell. Identical resistance means this is R, and R. Okay. The voltmeter reads 8 volts. Okay. What is the reading on voltmeter P and what is the EMF of the cell? Okay. If the voltmeter Q reads 8 volts, that means this resistor R will be getting 4 volts and this resistor R will also be getting 4 volts. Why? Because they are identical resistors, so voltage will get evenly divided. And if each resistor is getting 4 volts, this R resistor connected parallel to the voltmeter P will also receive 4 volts. So the reading on P will be what? 4 volts. C and D gets cancelled out. What will be the EMF? 4 plus 4 plus 4, that is 12. B is your answer. Let's further move ahead. Let's see this. A battery of electromotive force 10 volts is connected to a resistor. A charge of 2 coulombs passes through the resistor. Okay. You have your charge Q, you have your voltage V. Okay. How much work is done as the charge passes through the resistor? Okay. Work done. Or you can say voltage is equals to what? Work done over charge. If I want to calculate work done, what will I do? Voltage into charge. Your voltage is 10, your charge is 2. Work done comes out to be 20 joules. D is your answer. Let's further move ahead. Let's see this. A wire of length 0.5 meters and cross sectional area 1 into 10 raised to the power of minus 6 has a resistance of R, that is 0.75 ohms. Okay. Another wire of the same material has a length of 2 meters. Okay. So the length has increased 4 times, 0.5 to 2 meters. Your length has become what? From L to 4L. What have we studied? Resistance is directly proportional to length. So if the length has become 4 times, the resistance will also become 4 times, from 0.75 to what? 3 ohms is your resistance. But this is not the final answer. If you closely see, there is something happening to area as well. Initially, the area was what? 1 into 10 raised to the power of minus 6. Now the area has halved, 0.5 into 10 raised to the power of minus 6. The area has halved. What will happen to the resistance? We remember resistance is inversely proportional to area. If the area has halved, what will happen to the resistance? It will double. The resistance was already 3 ohm. If we double this 3 ohm, it will become 6 ohm. D is your answer. Simple as that. Let's further move ahead. Let's see this. Which graph shows the relationship between current and voltage for a filament lamp? Okay. So if we remember from notes, the voltage versus current ratio for a filament lamp used to increase. Why? Because its resistance increases. As the resistance increases or the voltage versus current ratio increases, which thing will decrease? Current versus voltage will decrease. If voltage versus current is increasing, or you can say resistance is increasing, which thing will decrease? Current versus voltage. Hence, your current versus voltage graph will be a decreasing curve. Hence, your current versus voltage graph will be a decreasing curve. A is your answer. Simple. Let's see this. The diagram shows a circuit with a 5 volts power supply, 3 resistors, and 4 output terminals P, Q, R, S. Okay. Which between which pair of the terminals is there a potential difference of 1.5 volts? Okay. Which terminal will give an output of 1.5 volts? Okay. So you have 3 resistors currently. If you want to calculate the voltage across each resistor, how will you do that? We will apply the potential divider rule. Potential divider rule. What does that rule state? That rule states you will take the resistance across which you want the voltage divided by the total resistance 2 plus 5 plus 3, that is 10, multiplied by the total voltage, that is 5. This becomes 1, this becomes 2. 2 and 2 cancel. This means if I place a voltmeter across 2 ohms, I will get 1 volts as my answer. Let's calculate the voltage across 5 ohms resistor. I will take the 5 ohm divided by the total resistance multiplied by 5. This becomes 1, this becomes 2, this becomes 1, this becomes 2.5. So if I place a voltmeter across QR, I will get an answer of 2.5 volts. Now let's do the same thing with 3 ohm. 3 divided by 10 into 5, this becomes 1, this becomes 2. If I place a voltmeter across RS, I will get a voltage key value of 1.5 volts. So across which terminals will I get a voltage value of 1.5 volts? DRS is your answer. Let's further move ahead. At the time when the lamps are switched on, the filaments are cooled and the current is 4 times as large as the final current in the circuit. Okay. What is the initial current supplied by the mains? Okay. First of all, you need to understand that we have 8 lamps, something like this. Obviously, to draw them, let's draw them 3, 4, and 5, 6, 7, and let's say this is 8. Okay. So these are your 8 lamps. Okay. Connected in parallel, obviously, these look very crooked. And each of these lamp has a 60 volts power, 240 volts voltage. Power is equals to IV. Can you calculate the current? Yes, 60 divided by 240. Your current comes out to be 0.25 ampere. But you are missing one thing. Initially, the current was 4 times this value. So initially, each lamp had a current of what? 0.25 into 4, that is 1 ampere. And we have 8 lamps. So each lamp will have a current of 1 ampere. The total current is 8 ampere. D is your answer. Let's further move ahead. A thermistor warms up as the current in it increases. Okay. So basically, the resistance of thermistor decreases. We know voltage over current ratio of thermistor decreases. Okay. Which graph shows how the voltage across the thermistor varies as current through it is increased. So we have to see the voltage versus current graph. This is the correct voltage versus current graph, which is a decreasing curve. Simple as that. Let's further move ahead. Let's see this. A metal wire of length L and cross sectional area A has resistance R. Okay. A second wire is made from the same metal. It has length of 2L. L is increased from L to 2L. Your resistance goes from R to 2R. Okay. And a cross sectional area of 4A. Okay. So if your area is increasing from A to 4A, what will happen? We know resistance is inversely proportional to area. Your resistance will decrease by a factor of 4. 2R divided by 4. This will become R over 2. C is your answer. And why have I taken initial resistance as 2R? Because my length had doubled, so my resistance was initially doubled. Okay, so let's further move ahead. Okay, let's see this. A device that is used to give an electric shock to a patient's heart. It supplies an electric shock with an energy of this. Okay, at an average voltage of this for this milliseconds. What is the average current? Okay, so we know that voltage is equals to work done over charge. And we also know that charge is equals to current into time. So let's place it here. Voltage is equals to W over I T. What is your voltage? Your voltage is 2000. So let's place it here. Your voltage is 2000. Your work done is 240. Your current is I. Your time is 10 milliseconds. 10 into 10 is the power of minus 3. Let's calculate it. 2000 into 10 raised to the power of minus 3. Okay, divided, yeah, we will divide 240 by this. Your answer comes out to be 12 ampere is your answer. Have I calculated that correctly? Let me check that once again. So 240 in the numerator, 2000 here, multiplied by 10 milliseconds, 10 into 10 raised to the power of minus 3. Yeah, this comes out to be 12. C is your answer. Let's further move ahead. This is the same question. Okay, let's see this. A copper wire has resistance R. Another copper wire Y has twice the length. Okay. So if your L increases to 2L, your resistance will go from R to 2R. Okay. And half the cross sectional area. Okay. If your cross sectional area halves, what will happen? Resistance is inversely proportional to area. If your area halves, what will happen to your resistance? It will further double. So it goes from 2R till 4R. D is your answer. Let's further move ahead. A piece of wire has a resistance of 16 ohms. Okay, so initially the resistance is 16 ohms. The wire is 20 centimeter long and a cross sectional area of this. Okay. Which wire of the same material has a resistance of 8 ohms? Okay. So we have to make sure that a resistance halves. We have to half a resistance. Okay. If the length halves and the area also halves, so obviously there will be no effect. If the length halves and area doubles, obviously if your length halves and area doubles, your resistance will decrease 4 times. But I don't want that. I want the resistance to only half. You can say decrease 4 times. Okay, if your length remains the same and area halves, so your resistance will double. No benefit of that. If your length remains same and area doubles, what will happen? What have you studied? Resistance is inversely proportional to area. If area doubles, resistance will half. D is your answer. Perfect. This could be your option. Okay, let's see this. A piece of wire has a resistance of 16 ohms. Okay. Another wire made from the same material has 4 times the length. L increases to 4L. The resistance will 4 times as well. 16 into 4, that is 64 ohms. And twice the cross sectional area. Okay. If your area doubles, what will happen? Your resistance halves. So initially you had 64. This will get divided by 2. This will become 32. B is your answer. Which electric symbol represents a fuse? A is not a fuse, B is a fuse, C is a motor, D is a lamp. Let's further move ahead. Which circuit is connected to measure the current in the fixed resistor and the potential difference across the same resistor? You have to connect voltmeters and ammeters in such a way that they measure the current in the fixed resistor and the voltage in the fixed resistor. Always remember, voltmeter is attached in parallel, as you can see here. It is attached in parallel. And ammeter is attached in series with the fixed resistor. A is your answer. B cannot be your answer. C cannot be your answer. D cannot be your answer. Always remember, voltmeters are attached in parallel, ammeters are attached in series. Okay, let's see this. The circuit diagram shows a variable resistor R connected in parallel to a lower half of a potential divider. Okay. The resistance of R is increased. Okay, so basically you increase R. If you increase the resistance R, what will happen? The voltage V2 will increase. Why? Because we have studied voltage is directly proportional to resistance in series. If you increase the resistance, the voltage across V2 will increase. However, if the voltage across V2 increases, the voltage across V1 will decrease. Obviously, this seems quite counterintuitive at the first glance, so I will give you an example of numerical here. Let's say the battery at 6 volts initially. Initially, this was getting 3 volts and this was also getting 3 volts. Now the resistance of R increases. This 3 volts changes to 4 volts. Will this remain 3 volts? No, this cannot remain 3 volts because if you add up the voltages now, it will be equal to 7 volts. Hence, this will drop down to what? 2 volts. So V2 increases, V1 decreases. V2 increases, V1 decreases. B is your answer. Okay, let's see this. A thermistor and a light dependent resistor LDR are connected in series. Okay, always remember for a thermistor, as temperature increases, your resistance decreases. Always remember, for a thermistor, as temperature increases, resistance decreases. And for an LDR, as light intensity increases, your resistance decreases. Okay. Which condition gives the least resistance? Okay. Which condition will give the least resistance? Okay. This is a thermistor, this is an LDR. Okay. For the least resistance of a thermistor, you want the temperature to be highest. So cold options will get cancelled out, hot and hot. For the least resistance of an LDR, you want the environment to be bright or you want light. D is your answer. Let's see this. The diagram shows an alarm system. What happens when battery B or battery P is disconnected? If battery P gets disconnected, iron will get demagnetized. It will drop and the bell will start to ring. A is your answer. Okay, let's see this. The battery in a circuit contains two identical cells connected in parallel. Okay. If the cells are connected in parallel, the total voltage or EMF will remain same, that is 2 volts. Which row shows the relationship between current I1 and I2 and gives the electromotive force of the battery? As I have told you, you can connect thousands of cells in parallel, but the EMF or voltage will remain same as the voltage of 1 volt, as the voltage of one battery. B and D are incorrect. and I1 is equals to I2. C is your answer. Which circuit contains a fuse and a diode? Okay. A contains a diode but not a fuse. B contains a fuse but not a diode. C contains neither a fuse nor a diode. D is your correct option. Here you have a diode. Where is your fuse? This is your fuse. Why is a reed relay used in a switching circuit? Okay, why is a reed relay used in a switching circuit? To switch on a large current using a small current. That's why reed relays are sometimes known as what? Switching devices. Okay, let's see this. In the circuit shown, R is a light dependent resistor. Its resistance decreases when the light intensity shining on it increases. Okay. The light intensity on R increases. Okay. So this resistance of R will decrease. Okay. What happens to the brightness of the two lamps L1 and L2? Okay. Now, I think the best possible way to explain this is to give you numerical values. Okay. Let's say you have a battery of 6 volts here. Okay. This branch will get 6 volts, and let's say initially we are getting 3 volts here and 3 volts here. Okay. As the resistance of LDR decreases, what have we studied? Voltage is directly proportional to resistance. As the light intensity increases, the resistance will decrease. As the resistance decreases, the voltage across LDR will decrease. Now, the voltage across LDR will, let's say, be 2 volts. The extra voltage will go to what? To the lamp. This will become 4 volts. So, the brightness of L2 will increase. You can cancel out the options for decreases. After this entire process, does anything happen to L1? L1 is still receiving the same 6 volts that it was initially receiving. The voltage of L1 remains unchanged. It neither increases nor decreases. So the brightness of L1 stays the same. D is your answer. Let's further move ahead. Let's further our questions. Okay, let's see this. A battery of EMF E is connected in a circuit containing 3 resistors. Okay. The reading of 2 ammeters and a voltmeter are shown. Okay, 2 ammeters and a voltmeter are shown. This is your ammeter reading. This is your ammeter reading. This is your voltmeter reading, and I guess this is your voltmeter reading. Okay. I guess there are 3 ammeters. Yeah, 3 ammeters there. The readings of 2 ammeters, I don't know why that's written. Which readings are shown on ammeter X and voltmeter Y? Okay. What are the readings shown on ammeter X? That is this one, and voltmeter Y, that is this one. Okay. We have to calculate that. Very, very easy. First of all, for ammeter X, can you realize if I have a current I naught here? If I have a current I naught here, it gets split up into I1 and this current at ammeter X. The current at X will be equal to what? I naught minus I1. C and D can get cancelled out. What will be the voltmeter reading across this voltmeter? EMF E minus this voltage V naught. A is your answer. Okay, let's see this. Two identical resistors connected in parallel have a total resistance of 4 ohms. Let's say this is your resistor R. Let's say this is your resistor R. Let's say they are connected in parallel. Their total resistance is 4 ohms. So 1 upon RT is equals to 1 upon R plus 1 upon R. Your RT is 4. 1 upon 4 is equals to 1 upon R plus 1 upon R. 1 upon 4 is equals to 2 over R. R is equals to 8 ohms. So each resistor is of 8 ohms. You have to calculate the resistance of two resistors in series. So 8 ohms and 8 ohms like this. What will be the combined resistance in series? 8 plus 8, 16 ohms. The diagram shows three 6 ohm resistors connected to give various total resistances. Okay. What is the difference between the smallest total resistance and the largest total resistance? Always remember the largest total resistance occurs when all resistors are connected in series. 6 plus 6 plus 6. When all are connected in series, this becomes 18 ohms. Okay. And the smallest possible resistance comes when? When all the resistors are connected in parallel. This is 6, this is 6, this is 6, 6, 6, 6. 1 over 6 plus 1 over 6 plus 1 over 6 is equals to 1 over RT. Your total resistance is 2 ohms. The smallest resistance occurs when all of them are connected in parallel. The largest resistance occurs when all of them are connected in series. 18 minus 2, the difference is 16 ohms. The diagram shows a battery of three 1.5 volt cells. What is an advantage of this arrangement of cells? The battery can supply a current for a longer amount of time than a 1 volt cell. Yes, this is an advantage of cells in parallel. The three 10 ohm resistors are connected together to form XYZ. Okay. What is the order of resistances of the network going from the smallest resistance to the largest resistance? The smallest resistance is of the one that have all connected in parallel, that is resistance X. C and D can get cancelled out. The largest resistance is of the circuit which has all of them connected in series. Why? X should be the smallest, all parallel. Y should be the largest, all series. B is your answer. Two resistors of resistances 30 ohms and 60 ohms are arranged in parallel. The current in the 30 ohm resistor is 0.6 ampere. What is the potential difference across the 60 ohm resistor? So you have to calculate the potential difference here. You must remember that the potential difference across the 60 ohm resistor is the same as the potential difference in this branch. V is equals to IR. Your current is 0.6, your resistance is 30, your voltage comes out to be 0.6 into 30. That is 18, I guess. 18 is your answer. B is your answer. So this marks the end of the past papers for current and electricity. The PDF is attached in the description. If you have any questions, you may ask.